I will just say a few words, and then Jimmy will be staying here answering questions. We have two facilities in Manchester now being installed, and they're looking at materials under extreme conditions. When we say extreme, what I meant is high temperature impact and strain rate, these effects. So we've got two facilities in here. The first one is what we call multi-dimensional high temperature facility. In this case in here, we heat materials up to about 1,000 degrees, and then we apply loads at the same time in different directions, multi-directions. So we have a testing facility to apply 3-axis loading up to 1,000 tons, 1,000 kilonewtons in 3 directions for compression, and then we can also do tensile testing in 2 directions, biaxial loading. And for the tensile testing machine, we can also then do high temperature fatigue testing as well. So that's then the first facility. The second facility, which Chimney is going to introduce, is this high speed, high strain rate, and high temperature testing facility. You have our contacts in there. So next slide, please, Joy. I'm just going to show you a few pictures of our facilities which are still being commissioned. So this is the first facility where we're testing materials under compression in 3 directions or tension in 2 directions at high temperatures. So this is one commissioning test where we have concrete cubes, where you can see in here we have actuators from 2 directions. In this case, there is another set of actuator in the other direction, and the actuators are heating our specimen by induction heating. And you can see on the right-hand side, the red hot of the specimen, as I said, it can go up to about 1,000 degrees, and the loads can be in any combination in 3 different directions. So that's compression test. Next slide, please, Joy. And this is the tensile test. Again, you can see the red hot specimen in machine, and in this case, we apply biaxial loading in 2 directions in any combination. This again can go up to 1,000 degrees, and the load is enough to fill the specimen in tension. In here, as in compression test, if the 3rd surface is not loaded up, is not covered, we have a digital imaging computer to a camera to look on the surface so that then we can acquire data in much more great detail. This just shows you sort of the load can be maintained where we increase the right-hand side. If we can't see my cursor, the load, blue line is load is maintained, and then the orange line is where the temperature is increased. And at the bottom sort of picture in it just show you we're doing high temperature fatigue testing. So we can then increase the specimen to whatever temperature we can have, and then cycle the load to introduce fatigue at high temperatures. So at the moment, the facilities are being built. This sort of facilities is being commissioned in the laboratories, installed in the laboratory, and is now being commissioned in the laboratory. So it should be then hopefully ready for use in the next few months. So that's me. Okay, so I'm going to stop in here. I think next slide, Jimmy is going to say a few words about the other facility.
Okay, thanks, Yung.
It's got 30 seconds.
I have to leave now. Sorry about
that.
I
just have a quick talk for the rest of the facilities. This is for the high speed, high strain rate, and high temperature testing facilities. The purpose of this is to get material properties out of these different environmental parameters. So it is normally related to the extreme loading conditions. So we have 2 split Hopkinson bar system, which are used mainly for the high strain rate combined with temperature and pressure. One is the 19 millimeter one is mainly for the metals. So we can test the samples from the minus nearly 200 degree to 1,200 degree Celsius, and the strain rate between 10 to the power 2 to 10 to the power 4. So this is roughly sufficient for the normal impact and blast loading in that scenarios. And we have a large diameter split Hopkinson bar, so that can be used for both tension, compression, with the environmental confinement pressure and the environmental temperature. So this is quite flexible, and it is a larger system, about nearly 20 meters long. So that is mainly for the concrete, because concrete you have the aggregate size, so we need a larger bar to make sure it covers sufficient, with the sufficient aggregate in a sample as the material. So those are
We're
two.
at time, I'm afraid.
Yeah, the next one, just one more.
It would have to be just seconds.
Yeah.
2 seconds.
So next one is for the loading system. So basically we can launch the impact speed from 500 to 5,000 meters per second. So that goes to the extreme loading conditions. And we have the various instrumentations like the high-speed camera, ultra-high-speed camera, and the flash X-ray, and so on to get the sensor. So that is really helpful to get all the data. Thank you.